AI reasoning has just taken a massive leap forward, and the open source community is leading the charge. A new model, trained on just 14% of the data used by its competitors, is outpacing industry giants. Meanwhile, another AI system is rewriting the rules of logical problem solving by thinking in hidden loops rather than following conventional step-by-step reasoning. For years, cutting-edge AI development was seen as something that only billion-dollar labs could achieve. However, these new models are proving that smarter design beats brute force. Let's break down exactly what's happening and how these new AI models are challenging some of the biggest names in artificial intelligence. OpenThinker 32B, the open source AI that's changing everything. One of the most exciting models shaking up the AI world right now is OpenThinker 32B. Developed by the OpenThoughts team, this model is making waves because of its efficiency and raw reasoning power. It is fine-tuned from Alibaba's Qwen 2.53 Top Instruct and comes packed with 32.8 billion parameters and a 16,000 token context window. Unlike proprietary models that train on massive datasets, OpenThinker 32B was trained using the OpenThoughts 114K dataset, which contains exactly 114,000 carefully curated training examples. These training examples come with detailed metadata, domain-specific guidance, and ground truth solutions. The team even used an AI-based judge to verify math proofs and coding solutions, ensuring that the model learns precise and accurate reasoning techniques. Training efficiency, faster learning with less data. OpenThinker 32B was trained using 3 epochs, meaning it went through its dataset 3 times, and relied on a Gaussian learning rate scheduler to gradually adjust its learning speed. The entire training process was completed using AWS SageMaker, running on 4 nodes with 8 H100 GPUs each. In just 90 hours, OpenThinker 32B was ready for testing. Additionally, an unverified dataset with 137,000 samples was trained separately on Italy's Leonardo supercomputer, which used 11,520 A100 GPU hours in just 30 hours. Even with this dataset, the fully verified version of OpenThinker 32B still outperformed it. How does OpenThinker 32B compare to other AI models? Benchmark results show that OpenThinker 32B is competing head-to-head with some of the best proprietary models in the industry. On the Math 500 benchmark, it scored an impressive 90.6%, outperforming many big-name commercial models. On the GPQA Diamond benchmark, it scored 61.6%, showing strong problem-solving capabilities. For coding tasks, it achieved a 68.9% score on the LCBV2 benchmark, slightly lower than DeepSeek's 71.2%, but still competitive for an open-source model. The most shocking part is that OpenThinker 32B achieved these results using only 14% of the data that DeepSeek needed. DeepSeek R1 was trained on 800,000 examples, while OpenThinker only used 114,000 examples. This level of data efficiency makes OpenThinker 32B a major success for open source AI. The fact that it competes with, and in some cases surpasses, DeepSeek despite using a fraction of the training data is a significant milestone. The model is already being fine-tuned by the open source community, which means its performance could improve even further over time. For those who do not have access to high-end GPUs, OpenThinker also comes in a 7B parameter variant, making it accessible to researchers and AI enthusiasts with limited hardware. Huygen 3.5B, a new approach to AI reasoning. Another groundbreaking model challenging the status quo is Huygen 3.5B, which introduces a new way of reasoning that is unlike anything we've seen before. Developed by an international team from institutions including the Ellis Institute, the Max Planck Institute for Intelligent Systems, the University of Maryland, and Lawrence Livermore National Laboratory, Huygen 3.5 billion is designed to think in hidden loops rather than following conventional step-by-step reasoning. Latent reasoning, thinking without explicit steps. Most AI models rely on chain-of-thought reasoning, which means they explicitly generate each step in their reasoning process. Huggin 3.5b, however, keeps most of its reasoning hidden. Rather than producing visible intermediate steps, it refines its internal thought process in the background until it reaches a final answer. This method allows the model to reason through complex problems without using extra tokens or a larger context window, making it more memory efficient than traditional AI reasoning models. Recurrent depth, the hidden loop mechanism. Huggin 3.5b's architecture is built around something called recurrent depth. Instead of processing an input once and producing an immediate response, Huggin loops through its hidden state multiple times, effectively running multiple passes over the same internal representation before finalizing an answer. This process is similar to how a human mentally works through a math problem, making corrections and refinements along the way before arriving at a final solution. The advantage of this approach is that Huggin does not need to generate long chains of text to show its work. It refines its response internally, making it more efficient when handling multi-step logical problems like mathematical proofs or software debugging. How Huggin 3.5 billion was trained. Huggin 3.5 billion was trained on 800 billion tokens, covering a wide range of domains including general text, code, and mathematical reasoning. Unlike many AI models that rely on memorization, Huggin was specifically designed to go beyond single-shot problem solving. Its architecture encourages it to think and refine answers dynamically, instead of just recalling previously seen patterns. Benchmark performance. Beating larger models. Despite having only 3.5 billion parameters, Huggin 3.5b outperformed larger models like Pythia 6.9b and Pythia 12b on multiple reasoning-heavy benchmarks. On the ARC AI Reasoning Challenge dataset, it showed significant improvement over existing models. On GSM-8K, a benchmark for math reasoning, it achieved results comparable to much larger models. Adaptive processing. Adjusting complexity on demand. One of Huggin 3.5b's most innovative features is adaptive processing. For simple problems, it runs only a few inference loops, speeding up response time and reducing compute usage. For complex problems, it increases the number of reasoning loops, allowing it to refine its answer with multiple passes. This ability to adjust computational effort based on task difficulty makes Huggin 3.5 billion highly efficient for real-world applications, especially for users who need strong reasoning capabilities but want to conserve computing power. The future of AI reasoning open thinker. 32B and Huggin 3.5b represent a new wave of AI models that challenge the traditional brute force approach used by industry giants. OpenThinker proves that open source AI can achieve state-of-the-art performance while using significantly less data. Huggin 3.5b introduces an entirely new method of reasoning, allowing AI to think in hidden loops instead of generating unnecessary step-by-step explanations. Both models highlight the fact that smarter architectures and efficient training techniques can outperform models trained on massive datasets. With the rapid advancements in AI, we are seeing a fundamental shift in how reasoning models are built. The future belongs to more intelligent, adaptive, and resource-efficient AI systems. What do you think about these new breakthroughs? Can open source models like OpenThinker 32b compete with proprietary AI from companies like OpenAI and DeepSeek? Let me know in the comments. Thanks for watching, and I will see you in the next one.